This is problem F on the AtCoder Educational DP contest. So let's look through the problems. LCS just means longest common subsequence, which might reveal the problem. There's another classical DP problem. Okay, so you have two strings S and T. Their maximum length is 3000. We can work with that. And you just need to find the longest, subsequence, that is subsequence of both S and T. So let's see how we can work with this. Essentially, subsequence is just you take a string and you keep it in the same order and you omit any one of the characters. So basically you keep the same ordering, but you can delete any characters. Okay, so looks like it's 3000, right? So if we have S and we have T and the length of S is N, length of T is M, we can work with a complexity of N times M, okay? So let's see what we can do. So what we want to do in DP is try to solve this problem using smaller problems we've solved in the past. So if you're looking at this, for example, right, A X Y B and AB Y X B. How do we do this, right? So since we're just deleting characters, right, all it has to be is in order. So at first, if we just look at these characters, the longest subsequence is A. Okay, now if we try to consider these characters, okay, still nothing we can do. So longest is still A. Then we go to step this one forward. Looks like we can't do anything. Step this one forward. Okay, again, it doesn't really look like we can do anything. Okay, then we step this guy forward. Okay, looks like these two are the same. Now we can add a Y, right? Now we, let's say we look at this. It's still AY. Let's say we do this, right? Now it's AYB, right? But, let's say we would look like this. Now, in this case, the largest common subsequence is just AB. So, maybe in some case, this would be the optimal, subsequence to take. I don't know, maybe in some case you'd rather do this, right? So let's say if there's, some combinations A, X, Y, B, B, AA, and here is A, B, B, A, A, and then Y, X, B, right? So now you wouldn't, if you're here, the longest subsequence is clearly, AY, but in actuality, right, at the very end, the longest subsequence would be A, B, B, A, A, okay? So how do we look at this? Let's simplify this problem a little bit, okay? Give it some more clear bounds. If we say, given two positions, I and J, for each of these strings, let's say J here is 3, right? The first three values, and I here is, I don't know, right? 4, the first 4 values. What's the maximum we can use here? And since we're doing DP, let's see if we can answer this using given we know all the previous answers. Okay, so here I and J, here they're not really the same, so we can't consider that, right? But if we go to I minus 1, we can see that the two are the same now. So now, okay, we see if we can find out what's there before when it's I minus 1 and J, we can simply add the maximum here, and if we add 1, then we'll get the value, we'll get the answer for J and I. So this is essentially what we're going to do. we are going to have a dp with dp of I and j, which are, the first j of s and the first, j values of t. So it's going to be at most m, at most t. And the way we're going to answer this is if s of, oops, it's terrible. If s of I is not equal to t of j, then clearly we can't just keep this value, right? So what we do is we do the maximum, this would basically, it just stores the length of the longest common subsequence, right? Max dp of saying, we step I back and we keep j, right? Or dp of I and j, right? So we know, okay, we can't, one of these characters is not going to be used, right? Because clearly it doesn't match up. So we have to step one of them back and we see which one's maximum, right? But if they're both the same, then no matter what, of course you're going to take it, right? We already have a +1. It's not going to get better than that. So now we just step both of them back and add 1 to it, right? Because we know for sure that whatever's happening before, if these last two are equal, for sure we'll have them in the last subsequence, right? Because let's say, j is the same as I minus 1. It still doesn't matter, right? It's still a +1. So this is our dp relation, and all you have to do is you would just loop through every single combination of I and j, right? So this would be 0 to n, 0 to m, and your complexity would be O of nm, which is under the time. So I hope this made sense. It's one of the classical DP problems. Thank you for watching, and I'll see you in the next video.